that function of the trainer input to allow 2 radios to control a single droid with just a single receiver setup. And you can have it so that basically your what we call the master radio, which is the one that's actually connected to the droid, can still operate as a single user if you're just wanting to operate it by yourself. And with the flick of a switch, you can pass over some or all of the control to the trainer to give, either divide up that input, or if you just want to have somebody be able to drive it around, but if they are about to run over a kid or something, you could take back the control. So again, my name is Ben, FrSky Ben. These are some of the ways you can get in touch with me. On Facebook, I have a YouTube channel that I try to post videos that kind of cover some of the droid builder programming stuff. I don't have that much content up yet, but I'm trying to work on getting more and more posted for you guys, and then my email address. So for the trainer input, there's a few different ways that you can connect the radios together. The most common way is to use a 3.5 millimeter mono audio jack cable. And basically this plugs in from one radio to another. And that's nice if you're both operating the droid from, 6 feet length or whatever you're going to be, close together. But if you're separated, like for example, you have somebody who's bringing the droid out from behind the scenes, and then another operator who's going to be like behind or in front of the stage or something operating from a distance, you can also use Bluetooth. And with Bluetooth, there's a few different options. It's not as reliable, of course, because of Bluetooth. But basically, there's these little head tracker units that, again, most of this stuff is kind of RC airplane stuff that's being repurposed for droid building and robotics. And typically what people will do with this head tracker is they'll put it on their goggle system. And as they move around, the camera on their drone or their airplane is going to also follow around and pan, tilt, and roll with their head movements. It's basically just an Arduino in here, a Nano BLE sense, and it gives you 3 axes, just your pan, tilt, and roll. It's very simple, but it's an open source project, so it can be modified. A smaller version of this is these little Seed Zhao NRF 52840 head trackers. And it's the same premise. It's basically just a little microcontroller with Bluetooth option and sends over 3 pan tilt from the little built-in gyro here. Alternative input methods are doing SBUS and PPM into the back of the module bay of the radio. So essentially what you can do is you can use an Arduino like this, just a regular Arduino Nano. And in this case, I have just a cheapy eBay joystick. And the Arduino Nano is just reading the analog inputs, and it can output either a PPM signal through the audio jack to feed it in to the audio jack, or you can run it in directly into the radio using basically a small backpack style thing that plugs into the external module bay of the radio. Another option is something that we actually make as a product, and it's called the FrSky Wireless Trainer Module. And basically what this is a receiver in a box, and you would bind to this with your
I just want people online couldn't see it, so yeah.
So this is a wireless trainer module, and this is basically just a receiver in a box. And you can bind to this with the student radio, plug it into the back of the instructor radio, and send the trainer commands from the student radio to the instructor radio. And then just to back up a little bit, here is the Bluetooth head tracker with the Arduino Nano BLE Sense. And then here is the Zhao NRF 58. And then another option is basically, like I was saying, with this little backpack, essentially all we're doing with this thing here that I'm doing with this is, again, reading the analog inputs from the joystick with the Arduino, generating an SBUS signal that's piping it into this little backpack that I've kind of custom made, and I'll get to that in a second. But with that little backpack, you can also basically just hook in a receiver itself that's piping SBUS into the trainer port. So the little backpack is essentially just one of these modules deconstructed. So I've taken off the shell and I'm basically just using this backboard here. I've kind of just trimmed off that bottom portion here. And on this board here, you have your connections that go into the external module bay with just a like 10-pin harness or something. I don't know how many pins it is. So that's basically what's inside of this little backpack here. And then we have basically just a regular external module bay cover that I've super glued on top of it. And from this cable, I've just taken ground, power, and the pin is called PXXN, and I'll show a diagram of that in a minute. So I'm only using three cables, 3 wires out of this to basically a servo connector. So when it's stripped down, it just looks like that.
You want me to switch back to your?
Yes.
There you go.
So with the trainer, there's kind of 3 main things to consider. There's your analog inputs, which are your sticks, your switches, your sliders, all of the physical buttons that you interact with. And those are pretty much like your raw inputs. Then there's your mixes, which is found under the mixer section. And that's where you do all your adjustments, like your travel rates, your offsets, your curves, differential, all these, the slow mixing, all the adjustments that you do to that raw analog inputs. And then finally, there's your channels, which are your outputs that you can set, like your min and max travel, centering, things, a few other adjustments within the outputs menu of the system. So this comes into play when you set up the trainer system, and I'll probably run into some problems with this because I haven't really tested this setup yet. So we'll see what kind of problems we run into, and then we'll work through them. So the trainer menu in Ethos can be found under the model setup, which is a little airplane icon. I've been trying to figure out a way to make this like a droid, like an R2 or something instead, but I haven't been able to get an image that works right. And it will get overwritten every time I update the radio. So eventually I'd like to find a way to skin the Ethos system, but I'm not there yet. So under model setup and then the trainer button, which is on the second page, that'll bring you into your trainer trainer menu. And I will pull up the simulator here. So under model setup, trainer, the trainer mode is normally going to be turned off because it's default to off. When you select whether you're doing an instructor or student, we use the term master slave, which is, we've gotten feedback, it's not that PC, so I try not to use those terms. The master is going to be your instructor radio. That's going to be the one that's actually connected to your droid, to your model. And when you select that option, you have your link mode, which can be the cable, Bluetooth, SBUS, or CPPM, which is PPM on the external module. So just for keeping things simple, I'll just choose the trainer cable on this one. The active condition is when is that trainer input going to actually be active? And it will still read the trainer inputs, but it won't do anything over on your outputs until that active condition is met. So I'll show that with the radios because I can't do it with the simulator. If you choose Bluetooth, it gives you the option to search up Bluetooth devices, which would be the student radio. You would connect to it, and then that would do your wireless trainer conditions. So for the, and backing up, for the active condition, you can usually typically with RC airplanes, they'll put it on a momentary switch. So if, you know, the student's about to crash, they just let go of the switch and they immediately have control over it again. But for a dual operator setup, you may want to just set it to be always on. That way the student radio can always be controlling that portion of the droid. Or you can, again, you can just set it to a switch position so that you can maintain full control with the single remote. And then if you put your SD to the down, SD switch to the down position, it would hand over a portion or all of the controls to the student radio. The little M up here on the top, if you guys ever see that, that means that your master trainer is active. And then if you see when I toggle that off, it becomes off. The slave setting or the student setting is more simple. Basically, you just choose which link mode you're going to be using, and that's really about it. So back on the master or the instructor side, when this, when you connect the trainer, you have all these options for all these channels here. And you can see that for channels 1 through 4, it's replacing your basic analog inputs, the aileron, elevator, throttle, and rudder. And again, that's replacing the raw inputs on the radio. So before the mixing happens, you can edit that. And instead of replacing your analog aileron, you can actually have it replace it at the output level, the channel level. And where that comes into play is if you're using mixing on your channels and you have the same model file copied to both radios, because if you have a 50% weight on your aileron channel over here, and then you copy that model file and have 50% weight over here, you're compounding that mixer. So you're taking 50% of 50%, and you're going to have even less travel. So that's where you would want to replace at the channel level, because you're also doing the mixing on the student radio. So that's where things kind of get a little bit muddy and mixed up, and some of the problems that I may run into when I start to do my demonstration here. So you can also use the trainer inputs as a source for your mixes. So instead of them either always overriding your analogs or even just on a simple switch, you can come into the mixer sources and set them as a source. And then again, adjust your active conditions so that when you flick a switch, it's going to read those trainer inputs and feed them into whatever mixes you're doing on the radio. So that's just an ethos. There's kind of 4 different ways or 5 different ways to do just about everything. And this is just an alternative way of getting the input sources from the student radio to the output sources of the instructor radio. So the external module, and I probably should have moved this slide up further. These are the pins that you would use for making that backpack that I was showing earlier. You basically have your ground, your V main, your battery power, and the PXXN, and that's what that SBUS and CPPM external module bay setting in the trainer menu is going to be reading from. So let's see. So on this radio, I have the instructor set up here, and unfortunately there's some glare that I have to deal with. So let me rearrange here. And actually let me do, oops. Okay, so over here I have kind of just a little mock-up of a droid that is easier to show on a table. And basically you just have your drive wheels and a little dome that I cut out of a plastic bottle. So, and I'm running this off of a TD-R18. And from my master or the instructor radio, as I push forward, the droid would drive forward, pull back, drives back, left, they rotate opposite to each other, and then right, they rotate opposite to each other. I don't know if the camera's really picking that up that well. And of course, just like everything, I have a little bit of trouble with these droids. And then what did I set the dome up to? And there's the dome spinning. And right now, this is all just coming from the instructor radio. That's the white radio on my left. The student radio is not doing anything. So on the student radio, I'll go into the trainer output, and I'm going to fly over here, bugging the crap out of me now, and set this to the slave mode. And actually, I'll do everything by Bluetooth. So I'll set it to Bluetooth, and I have the wireless address here, which is like a FBFF9. And then on the master radio here, we'll go into trainer, set it to Bluetooth. I'll search for devices. There are a lot of Bluetooth devices. So I may just back up and go by the cable method. I just wasn't sure if that cable is going to reach or not. All right, let's just back up and go cable. And on the top of the radios, there's actually two 3.5 jacks. One is the audio jack for your headphones. It has a little headphone. And the one that I'm using for the trainer cable is labeled DSC. And that's like a legacy term from old Futaba radios. It's direct servo control. So now that I've got them connected, you can see actually there are some inputs being recognized here on the instructor radio. And as I move the sticks on the student radio, the inputs are being reflected on the instructor radio. And right now I have the active condition set to the SC switch down position, which is off. So when I move the sticks on the student radio, you can see nothing's actually happening with the droid itself or on the output screen of the instructor radio. When I toggle that on, and there's the problems that I'm running into. So basically I'm sending some channel here into the dome that it's not liking. So let me back out here and go to, let's see, channel 3. This fly will not leave me alone. Okay, let me back up over here. Maybe it is a trainer setting here that I've missed. Place droid. Yeah, that should be it. Well, let's just change it. There we go. So somewhere in this line, I've messed something up. And I was sending it in as a replacement for, I guess, wrong channel here. Now I can actually control the dome from the student radio. And it's also controlling the drive as well, which, usually you want one person to be driving and another person to be controlling, like the dome, for example. So to disallow this drive mechanism from the student radio on the instructor side of things, you can just come over to these two drive channels here, which is going to be these two that are moving on the top. And instead of using them as a replace, you can just say off. Oops. Or you can also say, yeah, off. And now I cannot drive it. I can only control the dome. So by manipulating a lot of the settings here, you can control the different aspects of the trainer setup, the dual operator setup. And as I was saying earlier, the default is that it's going to be replacing the analog inputs at the pre-mixing level. So right now I have only the basic 4 channels coming in. Let's see, what is this? Okay, so on the instructor radio, I have this servo connected to my SC switch, and that's on channel 4. And even though I'm getting channel 4 moving on the instructor radio, the servo is not doing anything because it's not replacing channel 4. It's replacing my left joystick X, which is left and right, basically. So what I would need to do in this case is actually have it, again, instead of replacing the analog input, have it replace the output, which I have it labeled lights because I had a little light hooked up to it, but I burnt that out at the start of this event. So that's not going to work. And why is it not working? So let's see, channel 4. Oh, there we go. I need to actually enable the trainer input. So now that I've got that trainer input replacing the channel instead of just a stick, it's when I flick the channel 4 switch, I can control that servo. Now again, if you have mixing set up, so if I'm replacing, instead of the channel, I'm replacing, oh, I can't replace a switch. So let's change over here. So for my servo, which I have labeled as lights, I'll set that to the slider right. So now it's on the right slider. And this is moving 180 degrees. I'll adjust the weight so that it's moving 50%. So now it's only moving 90 degrees. And then on the student radio, well, actually on the instructor radio, I can just do it this way. Hold on, let me delete these because they're going ballistic. All right. Under the trainer for my channel 4, instead of replacing or the channel, I'll have it replace the right slider. Get my fingers to work here. Just do this. Oh. Why is that not working? All right. So this switch will replace the slider. And you can see that it's still only taking that 50% weight because that weight is set on the instructor radio, and it's replacing that slider at the analog level. And again, if I come over here, for example, I copied that model file to this radio, and I had my channel 4 also set to 50% of weight. Now I have even shorter. It's because it's taking sending 50% of the trainer signal to the instructor radio, and then the instructor radio is taking that at the analog level, applying 50% on the mix, and the actual output is 50% of 50%, so 25%. So those are a couple things that you just need to kind of be a little bit aware of when you're trying to set up the dual operator setup. If you're wanting to do only pass over certain control, again, there's a few different ways of doing that. You can set all of those settings under the trainer setup. So you can disable certain output channels, to have no destination for like your drives, to just completely disable them. Or under your mixes, you can come in here and basically only allow that. You would basically have your active condition set so that if the switch is in one position, you have control. And if the switch is in another position, so let's just say, let's clone this one. For this, I'll say when this D switch is up, I have control. And when the D switch is down, I will give the control to the trainer channel 1. And then as I toggle between the two switch positions, it's only going to allow that mix to be active by whichever position of the switch that you're allowing. So the trainer system can be pretty basic as far as just having 4 channels. Like normally with airplanes, it's kind of just 4 channels. You're mostly giving the control of the sticks over for your basic control surfaces: aileron, elevator, throttle, and rudder. But when you have more complex airplanes that have like landing gear and smoke systems and flaps and all this other crap, then it becomes a bit more complex. And the same would go for the droids and robots as well. So you can choose to have just a couple basic channels coming through that are just like your dome movements or other peripheral stuff, or you can have the full control going over from one to another. So let's see how I'm doing on time. All right, good. The next thing I want to show is how some of these peripherals here work. So I'll start with the Bluetooth head tracker, and let's see what's easiest to do that with. Probably this one here. So we'll see if I can get this one working. And actually, I need to grab another cable for this one. So under trainer, I'll set this to Bluetooth and let me power this one down. And sorry, let me grab one cable. So I will search for devices, see if this works or not. Bluetooth device connected. So getting inputs here. UD74. I think that's the right one. All right, well, Bluetooth, I'm not going to be able to show you. So I'll just move on to the next one. So this is just the basic Arduino setup here. And it's just reading the analog inputs from the joystick and feeding it in through the PPM cable directly to the top of the radio. So this is something basically like a basic proof of concept that you would be able to build and have a single-handed joystick that you could operate, and you can see that it's outputting the signal into the trainer input that you could feed in and override some of your channels just like you normally would with the full-size radio. So you can still, in a sense, divide up control by just having a little simplified joystick like this. With the Nano, it only has 8 analog inputs and 8 digital inputs. If you need more, that's where this Mega comes into play, because it can have up to 16 analog inputs and like 52 digital inputs, but you're still limited to 16 channels over the SBUS. And that's, I think I've pretty much covered everything that I needed to talk about. So does anybody have any questions?
All right, coming around.
So for the trainer mode, sorry, I had my coffee. For the trainer mode, why not use 2.4 or the 900 megahertz instead of the Bluetooth? Because of the Bluetooth reliability, is there some other way to do that, or?
Yeah, so if you could use either this module that we make, that this is basically just a receiver in a box, or you can literally just buy any receiver that outputs SBUS, like even a Futaba receiver, and pipe that SBUS into a backpack, basically like this, that that I have here. Oh, I'm all tangled up. And this will feed in the SBUS signal to the back of the radio. So this, all that it's looking for is 16 channel SBUS signal. So if you had a receiver, you could essentially bind your trainer radio to, or the student radio to this receiver, and now you're operating over 2.4 gigahertz instead of a Bluetooth link. An off-the-shelf solution for our stuff is the wireless trainer module, which, like I said, is basically a receiver in a box that you can bind it to any of our radios, and then it will connect to the back of the radio. And it's essentially this here. It's just a receiver with feeding the connections, the SBUS into the back of the radio. With this, you have a little bit of flexibility, because I mean, theoretically, you could have a Spectrum, somebody who has a Spectrum or other brand radio, and connect the SBUS signal from those other receivers, and then pipe it into the FrSky radio system. So should be, I haven't tested it, compatible with other brand systems just through that method.
Any other questions?
I'm gonna go there. So we'll go here, then you, then you. Okay.
Out of curiosity, are you able to have more than one trainer on the same radio? So like
No.
you'd have 3 radios we're puppeting?
Well, yes and no. So yes, if you build something like the Arduino setup, you could again, it's just reading pots and switches, and you could theoretically have two sets of joysticks feeding into a single Arduino and then feeding that one PPM signal into the radio. And actually, I did remember one thing that I haven't talked about yet, but the radio, you can only technically have one trainer input, but using something like a customized solution, you could build it out to have multiple joysticks. And basically, let me show what I'm doing with this. With this Arduino, I'll show my code here and kind of walk through that. That was the one thing that I was going to do. Downloads.
I'll switch hands. There you go. There's your computer. That's what you want, right?
Yep.
Right.
All right. So the code that I'm running on both of these is kind of complex, but kind of simple at the same time. Up at the top, I basically just have some debug values for if I need to get some debug information over serial. The PPM pin that is basically feeding into the audio jack here. Some basic signal generation stuff like the PWM centers, minimum and maximum that the radio is looking for. The PPM signal configuration, which is the channel maximum number of channels, the frame length, the pulse length. Again, PPM is looking for different minimum, maximum, and center. So kind of have to play around. I had to play around with these values to see what produced in the end, what the radio was looking for. And then the SBUS signal configuration, which again, is basically just a bunch of, it's all honestly, mostly stuff that I've copy pasted from other people's hard work. And I have the references here for like the PPM code and the SBUS code commented up here. The analog input pins. So the minimum in analog value, usually they're 0 to 1023 is what the Arduino reads. The pins that are defined for my analog inputs. So I'm using just basically all of them, analog 0 through analog 15. The button pins, which are the digital pins. And then the axes, which are basically 16 analog axes that I'm reading the current value, the raw value, or the value that I'm converting after like I apply deadband and stuff, the raw value, and then the old value. Excuse me. The maps are same for the digital inputs. I'm sorry, the maps are the minimum and maximum and the center for the different analog inputs, which are the like 988, 1500, 2012. A calibration, which I'm really not doing that much with this except for the deadband, but it's just basically like if the joystick is reading a little bit off center, you can adjust the PWM center to get the value to output at 1500 instead of like 1497 or something. And then the deadband is of course just a deadband, so there's a little bit of fluctuation in the analog inputs. Here's the button matrix, which again captures the current value, the raw value, and then the old value for debouncing, just some other basic variables. The SBUS prepare packet, this is part of that SBUS code that I have commented at the start. Basically just puts together all the SBUS packets for the SBUS signal that is generating out, the setup function. So first I initialize all the analog and digital pin states, set the pin modes for the PPM pins, initialize LED for the LED feedback. What's kind of neat is when it's outputting the PPM, there's a little LED on there, and as you shake it back and forth, you can actually see the PPM like breaking out into the different pulse width or whatever. I'm not that technical, to be honest, so I don't know what the exact terminology is for it, but so it'd be that.
Okay, let me switch
Yeah.
cameras. There you go.
So you can see it's kind of got that break in the camera. It probably doesn't have quite the refresh rate for it. It's easier to see with the naked eye, but essentially you'll see like the 8 channels broken out, like with spaces in between as you wave it back and forth. It's just kind of a neat little thing that gives you a visual feedback that it's actually generating PPM signal. So here's basically just initializing some of the default values so that everything's kind of start. Oh, I'm sorry. Switch me back to the, please. Thank you. Sorry. Initializing just some of the default PPM and SBUS values so that everything kind of starts at center instead of being like minimum and maximum, throwing your servos all around. Some timer clock stuff, which is again, copy paste. And then my main loop, basically here I define all the channel selections. So like I have my analog channels on 1, 2, 9, and 10, button channels on 3 and 11, which is the clicky button on the stick. This 4, 5, 6, 12, 13, 14, they're just outputting a fixed 1500 because I'm not really using those ones. And then I have a variable signal generator that basically just works its way up, works its way down, works its way up, and vice versa. And so those are outputting on 7, 8, 15, and 16. So you can kind of easily define which channels you want to read pots from, which ones you want to read digital buttons from, and which other ones you're really not using at all. The loop to read inputs. So here I'm just reading all the analog and digital button pins and analog pins. The main part of the loop is where I take that raw value and map it to PWM range between 988 to 2012, which is what the radio is expecting. Then I check it against the center offsets and deadbands to get it to where it needs to be. And the button can be modified to act as just momentary. So when you let go of it, it's on and off, or toggle it on and toggle it off. And that's what this code does here. And then this is the part of the code that actually builds the SBUS signal. So for each element in the analog and button matrices, it is setting them into an RC channel matrix or array from 1 to 16. Excuse me, sorry. And let's see, fixed center channels, variable signal generator. This is what makes those variable signals just kind of crawl up and crawl down and crawl up and crawl down. And then for the 8-channel PPM signal, it's just taking the first 8 channels from the SBUS because it's already done all the work to build the 16 channels for the SBUS. So rather than try to do all that again, I just look at the first 8 channels of SBUS. And then the output section where it, if I'm debugging, I can look at the PPM values that I'm trying to send out on the PPM signal. And here's where it prepares the SBUS signal. And again, if I'm debugging SBUS, it'll output what it's trying to send over SBUS. Otherwise, it just writes to the serial TX, the SBUS packets. And then the end of the loop is just some debouncing for the buttons. And then this code is leave this alone. You don't touch this part. I don't touch this part. It's copy paste from the PPM library that is linked at the top here, credited. So the code is fairly simple. It's literally just read the inputs and output the adjusted inputs or whatever. And as you saw when I had it plugged into the radio there, it was feeding in those buttons from this little joystick here. And again, really, these are just very basic pots or whatever. So pretty much any analog input or digital input you can dream of, you can have the Arduinos read and send it into the radio. So all right.
There was another question.
Hey, Ben, this is kind of a, if you set up the master radio and then you set up the trainer, is there a way to capture the trainer setup, like either back to the master radio so that it could be transferred again to a different trainer radio, so that the setup process doesn't have to be, you don't have to go through the whole thing again?
Yeah, so it's literally just another model file on the student radio that is set up to be the student trainer. And so if you've adjusted any of those analog inputs or whatever, most of the work is being done on the instructor radio, because that's where you're actually taking these basic, whatever the student radio is sending, and converting it and applying it to the output channels that you need them to feed into. So most of the work is done on the master radio, and to some degree, mostly just the channel order is what's important on the student radio, because you want to be sending, the inputs from your student radio in a specific order, so that they kind of make sense when they get to the master and start working their way through all the analog and mixing and all that other stuff.
Okay, there's another question.
So you made a comment about removing or being able to override the airplane icon.
Yes.
So can we also change or be able to change the terminology from aileron, rudder, elevator? Because that doesn't apply to droids.
Yeah, so I can actually show that if, bring up my computer, please. And that's what I've done with this radio here. Let's see. So let's get this to where we can see it. So under the system, which is this little gear icon here, you go to sticks, and you can rename the sticks here. So in my case, I labeled them as the left joystick X and Y and the right joystick X and Y, because that tells me, basically which stick exactly and which axes I'm working with. So so that's the way I've done it. And you can name them however you want: joystick 1, joystick 2, X and Y, or left, right, or however makes logical sense to you. But you want to do that before you start getting into your mixes and everything, because once you've got your mixes labeled as aileron and elevator and all these airplane terminology stuff, you can change the stick names here, but then you'd have to go back into your model and change your mixes names to be aileron instead of aileron elevator to be. Usually I try to name them logically according to their function, like dome spin, or drive forward reverse, or drive left right, or something that, so you have your mix name, which is to me the function that it's performing. And then you have your source or your input, which is what's feeding or driving that mix, what your input is for that mix. So yeah, one guy had a model and he had like 16 mixes on it, and they were all labeled free mix, and I'm like, what does what? So yeah, I'm not gonna name names.
Oh, you're not gonna call him out.
No.
All right. Do we have any other questions? I have a microphone. Not afraid to use it. I keep on seeing pushing their glasses up. I keep on thinking, okay, you want? No. Anybody else? Anybody? All right.
Somebody had asked about the Kyber setup. I can cover that.
Guys, do you want him to go over the Kyber setup?
Okay.
All right.
I can only cover some of the basics of the radio stuff, the stuff that's on like the web interface. I'm not set up to do that much yet. So let me grab the Kyber.
Bye, buddy. He's got an airplane to catch.
Green.
We do have only 5 minutes left, so
Okay.
I don't want to stress you any. I just want to let you know.
Yep, I could do it in 5 minutes.
Thank you.
So on the radio, I've got the Kyber pad pulled up. It's pretty complex setup here, but it basically starts with installing the script. So on your computer, when you connect the radio by USB, it'll pull up your radio drive just like a flash memory drive. And you install the Kyber script into the scripts folder. And in this case, I have Kyber pad and Kyber pad source. I'm sorry, just Kyber pad. And that has the main.lua C here, which is what displays on the screen here. Once you install the script, it's not going to actually show up here on the radio. First thing that you would need to do, and I'll just kind of start from fresh real quick, is your screen would look like this. You click on this little configure screens icon, add a new screen. You would choose the full page icon, not the full screen. And then you set that to Kyber pad. If you don't see Kyber pad listed here in your widget selection, it's not installed correctly to the scripts folder. So that's a kind of sign that things are not set up right. So with the latest version of Kyber pad, there's two parts to it. You have to enable the Kyber pad source. So if you don't have it enabled, I've programmed in a warning here that tells you you need to enable the Kyber pad source. So to enable Kyber pad source, you go model setup, Lua, and Kyber pad source. So model setup, Lua, and enable the Kyber pad source. And then that gives you your basic button layout here. Under the screen configuration where you added the Kyber pad screen, you have the configure button, and then that's where you can program in all of your button text, the colors for the buttons, and then the toggle pad sources that you're using for switching between the two pads, turning on your Wi-Fi and stuff like that. So there's a lot of other settings in here that I'm not going to cover. I'm just kind of giving a quick overview of the Kyber setup.
Switch warning.
So once you have the Kyber pad set up and programmed with all your call outs and everything, you would do the website setup, which again, I can't cover that in the 5 minutes that I have. Let's see. On the Kyber side of things, essentially there's a SBUS input, and it's labeled in the wiring diagram that they have in the manual. And so I just have a little micro receiver with the SBUS going into the Kyber. I have my audio files copied onto the SD card, and then I have this all configured on the web interface so that the buttons that I press on the Kyber pad will trigger the animations through the Maestro here. And let me just plug that in real quick. Set my
Sensor locked.
So, and I've only programmed just a single animation here just as an example, but you can see as I'm pressing the audio triggers on the Kyber pad, it's playing the appropriate sounds.
Leo Kenobi, years ago you served my father in the cloak.
Yeah. And then we're done. here. So yeah, I'm going to be doing videos, hopefully showing more of the Kyber pad setup and putting it on my YouTube, which was in the presentation there. So keep an eye on that.
Thank you, Ben. Thank you, everybody. It's been a great DroidCon. Thank you all.
Telemetry lost.
Hope to see you all again next time. Yeah, I'm gonna.